Hello! In this lesson, we will learn about midsegments of triangles and quadrilaterals. The learning goals are: understand the triangle midsegment theorem, understand the trapezoid midsegment theorem, and understand Varignon's theorem. Let's start with the triangle midsegment theorem. We'll show an example here, so you can understand how this theorem works. In this triangle, the lengths of the sides are 16, 14, and 10. And it has three different angles as shown by three different colors. Now we're going to take each side and we're going to divide by 2. 16 divided by 2 is 8, 14 divided by 2 is 7, and 10 divided by 2 is 5. So with these three dimensions that we created, we generate a smaller triangle, which is basically half this bigger triangle in dimensions, okay? Even though the dimensions are half these dimensions here, the angles are going to be the same because these two triangles are similar. Basically, is the same triangle, but smaller, half of that. But the angles are kept. So if we move this smaller triangle on top of the bigger one, we can appreciate that this point here is the midpoint of this side, because this is 8 and this is 8. And this is the midpoint of this side here, because this is 7 and this is 7. And by joining the points, the midpoints, we generate the midsegment. And that midsegment is half this side here. Okay? So we demonstrate that this midsegment is half this base. And that's basically what this triangle midsegment theorem says. Okay, it says that you have a triangle and you place the midpoint here, which divides this in half, and you place a midpoint here, which divides the other side in half, and you join those midpoints, you generate or you create the midsegment, which is this segment here. This is the base. Let's say if it measures 2x, the midsegment in length is going to be x, okay? And this midsegment is parallel to the base. That's what the midsegment theorem says about the triangles. A midsegment is always parallel to the third side, which is the base, and is exactly half the length of that base, okay? Okay. So now let's go into the trapezoid midsegment theorem. Here we have a trapezoid. This base of the trapezoid is A in length, and this is B. And we're going to draw this diagonal. So we separate the trapezoid into triangles. If we focus on this triangle first, and we draw the midpoint of this side of the triangle and the midpoint of this side of the triangle, and we join those midpoints, we create a midsegment, which we know because of the previous theorem that is going to be half in length this base. So if this is A, this is going to be A divided by 2. Now in this triangle, likewise, if we put the midpoint here of this side and we join these two midpoints, this midsegment here is going to be half this base here. So basically we show that if this base is A in length and this base is B in length, and we generate the midsegment of the trapezoid by joining the two midpoints, the length of this midsegment of the trapezoid is going to be a plus b divided by 2, where a and b are the lengths of the bases respectively. Okay? So that would be the trapezoid midsegment theorem. The trapezoid midsegment is always parallel to the bases, and its length is the average of the bases' lengths. All right? Okay. So in this example here, or in this problem here, they give you a trapezoid and they give you the two bases, the lengths of the two bases, 10 and 6. And they want you to calculate the length of the midsegment of the trapezoid. So it will be 10 plus 6 divided by 2, which is 16 divided by 2, which is 8. All right? Okay. Now let's go into Varignon's theorem. Varignon's theorem says that joining the midpoints of the sides of any quadrilateral creates a parallelogram. Basically, we have here a quadrilateral. It is an irregular quadrilateral. We're gonna place the midpoint of this side, of this side, of this side, and of this side. And we're gonna join those midpoints. So Varignon's theorem says that this figure that we create, this quadrilateral that we create, is a parallelogram. That's what the theorem says. So let's show, or let's prove the theorem in this figure. Okay, so basically we have to prove that these two sides of the quadrilateral we're creating are parallel to each other first. Okay, because a parallelogram has two pairs of parallel sides, two opposite sides that are parallel. So first we want to show that these two sides are parallel to each other. We draw this diagonal and we focus on this triangle, and based on the midsegment theorem, we know that this midsegment is parallel to this base. So this one is parallel to this, okay? That's based on the triangle midsegment theorem that we learned at the beginning of this lesson. Now, if we focus on this triangle here, this would be the midsegment, which would be parallel to this base. So this midsegment is parallel to this base. Therefore, we know that this guy here and this guy here are parallel to each other. Okay? So we show that these two sides are parallel. Now we have to show that the other two sides are parallel to each other. To do that, we're going to use the same principle that we used in the previous slide. We're going to draw a diagonal. We're going to focus on this triangle. And we can see that this midsegment in this triangle is parallel to this base. Now we focus on this yellow triangle. We also see that this midsegment will be parallel to this base. Since these three sides are parallel to each other, we already demonstrated that this guy here is parallel to this midsegment. Okay? So basically we have shown that these two are parallel to each other and these two are parallel to each other. Therefore, we prove Varignon's theorem that this figure that we form is a parallelogram. All right. Thank you very much for the attention.